students, this is what AC circuit with resistance only. Last class we discussed clearly about the Phasor diagram. Okay, in this class the continuation of the Phasor diagram is AC circuit with resistance only. We are all very well know about the battery or cell, which provides potential difference, which provides a steady current, which can be represented by positive and negative terminals. The longer terminal represent positive, the shorter terminal represent negative. When it is connected to a circuit, the current flows through the circuit from positive to negative. The arrow mark, the arrow head shows the way of current, where the current is flowing. The current is flowing from positive to negative. In the case of steady current, that means a DC. Battery provides a steady current, okay. But in the case of AC, an AC circuit with resistor, we may use this symbol. This is for AC, alternating current or alternating voltage. Alternating current or alternating voltage, the alternating voltage is represented by this type of symbol. Here the current is alternating, so it may go from both the directions, not only from this to this or this to this. So we may not use arrowheads for this AC type circuits, AC alternating voltage circuits. We may not use the arrowheads. That is one of the most important point. Okay. Now let us consider an alternating source of voltage. An alternating source of voltage. This is what? An alternating source of voltage which is connected across a resistance, which is connected across a resistor of resistance R. An alternating source of voltage, this is the symbol for alternating source of voltage, which is connected to a resistor of resistance R. Here arrowheads are not used because this is alternating current. Okay. What is the alternating voltage here? Let us check. The expression for alternating voltage is E equal to Em sin omega t or E naught sin omega t, where E is the instantaneous value of EMF and E naught is the peak value of EMF. Okay, this may written as E naught or EM. Okay, here I write E naught. Okay, E equal to E naught sin omega t is the alternating source of voltage, alternating voltage which is applied across the resistance R. Okay. When this alternating voltage produces an alternating current, the alternating current passes through the resistor R. So the resistor which opposes the alternating current. So in the next step, we divide both sides by R. Divide both sides by R. R is nothing but that is the resistance given by the resistor. So E by R is equal to E naught by R sin omega t. Where E by R is what? E by R is nothing but which is known as current I. E naught by R is nothing but the peak value of current I naught. So I equal to I naught sin omega t. This is one of the most important expression here because it represents instantaneous value of current. I is equal to I naught sin omega t. Here E equal to E naught sin omega t is the instantaneous value of EMF. This is instantaneous value of current. I equal to I naught sin omega t. Okay. Before comparing this equation, what is the opposition given? What is the opposition here for alternating current? When the alternating voltage is connected to a resistance R, it provides alternating current. The alternating current flows through the circuit. Here the opposition is nothing but that is the resistance provided by the resistor. Okay, this is the opposition in this case. Which case AC circuit with resistance, the opposition is only the resistance. So from this E by R equal to I, from this E by R is equal to I. So the opposition R equal to E by I, which is in accordance with Ohm's law. E by I is equal to R. Here R is the opposition given by the resistor R, which is called as resistance. Okay. Then we can compare these two expressions. E equal to E naught sin omega t and I is equal to I naught sin omega t. What is the phase difference between EMF and current here? How we calculate the phase difference? In the last lecture I told how how we can differentiate the phase difference, how we can calculate the phase difference. Here E equal to E naught sin omega t. This is what? Omega t. So I is equal to I naught sin, here also omega t. Both are at omega t. Both are at the same pace, omega t. So there is no phase difference between EMF and current. So the EMF and current are in same pace with each other. What is the meaning of same pace? Here there is no phase difference, that is otherwise known as same pace. What is the meaning of phase difference here? Here the phase difference means both EMF and current are moving together, moving simultaneously, moving at the same time, whatever it may be. Okay, the EMF and current are moving at the same time. There is no time lag between the EMF and the current. Otherwise, they are moving simultaneously, they are moving together. That means there is no time lag between the application of EMF and the prediction of alternating current, because they are moving same, they are moving randomly. Both EMF and current are moving. There is no phase difference between them. That is the most important point. So they are moving together. No phase difference. I write here, no phase difference between E and I. Okay, in the case of AC circuit with the resistance. Okay, how we represent the phase difference? There are three ways. One is mathematical expressions. Here I wrote here E equal to E naught sin omega t, I equal to I naught sin omega t. Both are at the same angle, sin omega t. So there is no phase difference between E and I. That is one of the way to represent. Okay. The second way is wave diagram. So we can draw the wave diagram. This is what? Wave diagram. In the x-axis we take t, in the y-axis E comma I, EMF comma current. Here the EMF is an alternating source of voltage. So this is alternating source of voltage. This is what? Peak voltage here. That is E naught, which is nothing but E naught. Okay, which attains E naught in the position. For example, okay, here how the current is moving. The current, how the current in this expression, calculate the current. E by R is equal to I. That means EMF divided by resistance is known as current. When the EMF is divided by the resistance, the current becomes less than the EMF. The value of current, the magnitude of current, instantaneous current will be less than the EMF. So when we draw the current, the amplitude of current become less than the EMF. So draw carefully. Okay, yes. So look at the diagram, wave diagram. Here they are starting with same pace. That means E is 0, I is 0. E is maximum, I is also maximum. This is what? I naught. So both are maximum at the same time. So they are both are moving together. The next E is minimum, I is also minimum. The next E is negative maximum, I is also negative maximum in this case, in this point, in this time. And then both are times 0. So at all the points they are at the same pace. That means they are moving together. There is no pace difference between them. The only difference is their amplitude. The amplitude of the current is less than the amplitude of EMF, because the reason is I told here. Okay, but there is no phase difference between them. All the two waves are moving together. EMF and current are moving together. There is no phase difference between them. At a particular time they are moving simultaneously. Okay, this is the representation of wave diagram, the representation of phase difference in the wave diagram. Okay, the next way of representation is Phasor diagram. You know very well about the Phasor diagram, I think. Okay, this is what Phasor diagram. And this, suppose this is what? E naught. Okay, it makes an angle omega t, because when this E naught vector reaches this point at a time t with an angular velocity omega, then theta equal to omega t. This we will study it in the last class. So when the E naught vector is here, it makes an angle omega t. What will be the current? The current is represented by the red line. The current is here. This is what? E naught vector. This is current. This is I naught. Okay. This makes an angle omega t from the origin, from the initial point. From the initial point, the current also makes an angle omega t. Both are at the same angle at the same time. That is the important point here. Both means the current and EMF are making an angle omega t from its initial position at the same time. So this means there is no phase difference between them. What is the instantaneous value of E naught? What is the instantaneous value here? The instantaneous value of E is E equal to E naught sine omega t, which is nothing but this projection. This projection represents instantaneous value of EMF. What is the instantaneous value of current? The instantaneous value of current is nothing but this. This is what? I equal to I naught sine omega t. The instantaneous value of current is less than the instantaneous value of EMF. I told the reason in that equation. Okay. So I equal to I naught sine omega t is this. E equal to E naught sine omega t is bigger than the value of instantaneous value of current. Okay, both are at the same angle at the same time. When the E vector is rotating along anti-clockwise, its value increases or decreases? Its value increases, because when it goes to 90 degrees, sin 90 is 1. So it attains its maximum value equal to E naught. Likewise, when the I vector is rotating, likewise the I vector, here the I vector is this. This I vector, this I naught vector is rotating here. It is also, its value is also increasing. So E increasing, I is also, E increasing, I is also increasing. E decreasing, then I is also decreasing. So both are moving together. Okay. So because, what is the reason behind it? Because there is no phase difference between them. So they are moving together. That is the reason. So this is about AC circuit with resistance. In AC circuit with resistance, the EMF and the current are in phase with each other. There is no phase difference with each other. They are moving together. Here the only opposition is resistance. Where here the only opposition is E by R is equal to E by I equal to R. The only opposition in the AC circuit with resistance is resistance. In the case of AC circuit with inductance and capacitance may vary. There may be some additional oppositions are there in that case, but here the only opposition is resistance. In any element, it may be a capacitor or inductor or resistor. Some things are well defined. Some things are well defined in the answer. What are they? First one is we should draw the diagram. Second, the mathematical expressions. The expressions E equal to E naught sine omega t. This is the expression for EMF. This is the expression for current. 1, 2, 3. The fourth thing is the opposition. What is the opposition given by the circuit when the resistor is connected or capacitor is connected or inductor is connected? The net effective opposition must be mentioned. That is the fourth point. Fifth one is what is the phase difference between them? There is no phase difference means we write no phase difference. Otherwise, if phase difference persists, we must mention. Okay. This is fifth. Sixth is wave diagram. Seventh one is Phasor diagram. 1, 2, 3, 4, 5, 6, 7. These all the 7 points are. 7 points should be mentioned in AC circuit with the resistor or inductor or capacitor. Okay. The next class we are going to discuss about AC circuit with inductor. I hope all of you should well understood this question very much. I hope you. Thank you. We will discuss in the next video. Thank you, my dear friends. Thank you.